Morning, everybody. Thank you for your time and attending this exciting ClearEdge customer webinar. As you're probably aware, ClearEdge 3D has a track record of technological innovation and thought leadership in the automated feature extraction, laser scanning, and 3D modeling space. The company was founded in 2006 by recognized experts in the fields of computer vision, hyperspectral data analysis, and LiDAR data analysis. First version of Edgewise Building focused on building and terrain modeling and was launched in 2009. The technology rapidly gained customer traction and industry acclaim. In 2011, Edgewise Plant was released, which was soon followed by Edgewise MEP. With Edgewise users reporting an average modeling time saving of up to 70%, I'd like to conclude the kickoff and the welcome, if you like, with a quote from the CEO of a ClearEdge client, and that is, if you're not modeling with Edgewise, your company may soon be at a competitive disadvantage. Now, I'd like to repeat that. If you're not modeling with Edgewise, your company may soon be at a competitive disadvantage. Aren't you glad you're attending the ClearEdge webinar? The solutions that will be covered today are Edgewise and Verity, and including a live demo. I'd like to do the introductions. My name is Michael Wood. I'm with Ideate and Worldview Technologies. And essentially, I focus on marketing and channel development across Africa. We are a market-making distributor, and we provide efficiency and profit to our channel partners by opening up access to various global brands such as Autodesk, ClearEdge, Topcon, and Esri. As you can see, we have a footprint right across Africa and are well represented. Today, we are really fortunate and excited to have with us Otto, who is no stranger to architecture, engineering, and construction, as well as the power and process industries. Otto is MD for ClearEdge for EMEA, and we're really looking forward to his sales insights. Also with us is Trevor, who's a technical modeling guru and has been involved in modeling training in support of literally anything that can be modeled. Trevor is a senior software specialist at ClearEdge, and we're really looking forward to learning from his technical knowledge. So as you can see, we're definitely in good hands. Questions are welcome using the chat function and will be dealt with as they are asked. Question polls will be used in each section, and these are anonymous, so no opinions can be shared. Also note that the webinar is recorded and links will be sent out to all people that have attended and registered. At this point, I'd like to hand over to Otto.
Hey, thank you, Michael. I appreciate that. First of all, I'd like to welcome everybody to our webinar. And as Michael said, you know, technology is certainly the way to the future. So either you're using it to your advantage or it's going to run you over and become a disadvantage. So technology is certainly a good thing. And what we're going to show you here today will show you, you know, the power of technology. Just one quick note, talk about technology. I don't know if you know this or not, but the F-16, we're talking about jets, the F-16 could fly faster going straight up than the F-4 can flying straight down. So imagine if you're sitting on a aircraft using the F-4 and you got the F-16. So technology really becomes a big advantage. So a little bit about ClearEdge. We're going to talk, very briefly about the company, an overview, and then we're going to split the presentations into two, Edgewise and into Verity, followed by a demonstration of each one. So Edgewise was founded in 2006 by experts in automated feature extraction. What that means is that we've been doing automation since 2006. So we truly are the pioneers. We've been doing it longer than anybody else. We have the most algorithms in automation. We are a subsidiary of Topcon, which is $1 billion company. So we definitely have a staying power. If you could hit next, please. Okay, our products are typically considered an investment as opposed to an expense because there's a very fast payback. So Edgewise automatically extracts critical features from your point cloud data and converts it automatically into a 3D CAD model that will reduce your modeling time by 50 to 75%. It's easy to use. It's compatible with all terrestrial scanners, and you can easily integrate with Rivet and various CAD programs. The workflow is here. It's you scan, you register for whatever software you're using for registration, then you use Edgewise to process it, and then you could export that 3D model that Edgewise extracts into various CAD or Rivet software. On the Verity side, we'll get into that after the Edgewise, but Verity is a construction verification software, and it analyzes point clouds of your as-built installed construction against the design fabrication model. So basically what it's doing is it's looking at the two and it's showing you any items that are out of tolerance, and it's giving you a heat map so you could very quickly see it, as well as tabular data. So it's very effective. Okay. It's a companion to Navisworks, so if you have Navisworks, it works with it. And the key factor is it can verify 100% of your work in the same time it takes today for contractors to spot check a small percentage of the project. Getting back to Edgewise, this is our portfolio, 4 modules. The building structure is pretty obvious. The difference between Plant and MEP, they have similar functionality. Plant is for the different CAD programs, and MEP is specifically for Rivet. Okay. On the plant side, it automates pipe extraction of a project. We have phenomenal quality assurance tools, so you can very quickly verify what was extracted automatically. We've got picture-perfect visualization engine, which we'll show you. The software is spec-driven, so everything that you place in the software has dimensionally correct, accurate information. You could easily create custom specs because the software sits in a spreadsheet. Next. We have both automatic and semi-automatic pipe editing tools, and our Smart Sheet technology allows you to add intelligence to every single pipe run. And that intelligent model, you could export to various CAD programs. And the CAD programs that we support today are CADWorks from Intergraph, Plant 3D from AutoCAD, Aviva's PDMS, the AutoPlant, which is a Bentley program, and then we have the generic Rivet, AutoCAD, as well as MicroStation. So those are the plugins that we support. A little bit about the savings. Here's a project that was done in Algeria, a large refinery, and I brought refinery because I know some of the countries have some large refineries. Okay. This one was a $2.6 billion upgrade. It was done in 3 phases. The documentation was either outdated or missing. It represented over 5,000 tying points, and because it was done in 3 phases, they had a comparison, right? Phase 1 and 2 were done traditionally. Phase 3 was done using Edgewise, and they found Edgewise was 75% faster over traditional approach. In essence, it reduced modeling time by 36 days, which was substantial. If you put man hours against that, it's quite a sum of money that was saved. It was a successful win-win project because the our contractor, next please, our contractor actually reduced his modeling man hours by 75%, and the client saved 36 days of project schedule. So they got the contractors off site 36 days sooner. Next. Here's another case study. This was quite successful. It was a chemical facility project. Next. It was an oil and gas additives plant built in the 1930s, so quite old. 1,600 scans. The challenges were the facility was operational. Up to 50% of the piping was not used, and they had a model 1 to 36 inch in very, very tight, congested areas. The deliverable were new P&ID sheets, piping, and structural models for maintenance purposes. Okay, next. They estimated 3,600 man hours for the modeling, right, for scan registration and the modeling itself. What Edgewise did was it reduced the man hours by 60%. So basically that 3,600 became 1,600, and they completed the modeling of the piping and the structure in Edgewise and a P&ID in AutoCAD. So that is a 2,000 man-hour savings, which is considerable on this project. So you could imagine how happy the client was. Next. On the MEP side, next. It's very similar to the plant, except it's specifically made for Rivet. Okay, you could go through this. We do have a case study next. where we'd like to show you some of the metrics. Okay, next. This was a hospital that was done here in the US. It was a $100 million expansion. As-built drawings were very old, unreliable. 1,400 scans collected. They budgeted 15 weeks to model, and with Edgewise, they finished it in 4. Again, a 75% savings. They directly exported from Edgewise, a one-click button right into Revit. Next, it was a win-win outcome because our client that did the scanning and modeling reduced his man hours by 75%. The hospital was extremely happy because they got contractors out of the hospital 11 weeks sooner. So it was truly a win-win. On the building side, next. We automatically extract walls and windows, and we directly export to Revit as Revit family objects. And we're getting exact as-built walls as opposed to as-designed walls. And you'll see we've got a really nice QA program so you can see how the walls line up. Next. On the structural side, we export, we actually could extract steel and concrete. And you don't need to clean the point cloud at all in order to extract because we're extracting from a catalog. Okay, so everything comes out of a catalog when it's extracting the steel. Next. We have a very good QA system and editing tools, which we've gotten a lot of feedback from clients on how well it works, and we'll show you how that works. You can very quickly see how the two line up. The point cloud that was a scan and what was extracted out of the catalog. We also have a gridded pattern extraction, which automates structural extraction. And again, we have direct integration into either Revit or one of the CAD programs. In this case, I'd like to turn it over to Trevor. And before we get into variety, Trevor's going to take us through a demo of the Edgewise. So again, if you have questions, now's the time to ask on anything I presented. If not, you could also ask questions as we go through the demo. So with this, I'll turn it over to Trevor. And while we're turning it over, does anybody have any questions?
Otto, would you like to run your poll, Otto, and ask a couple of questions?
I'm sorry, could you repeat that?
Would you like to run a poll and ask the audience a couple of questions?
Yeah, do you have the poll ready to ask him?
Yeah, we do. So
Okay.
You'll find some of the questions popping up on your screen right now. If you just want to complete them for us, that'll be great.
Okay. Yeah, if you could complete it, it'll give us a good gauge as to you know, some of your you know, challenges and requirements on a project. So we'll give the audience a minute or two. If you could complete this, that would be great. And then when we're done, we'll be able to see the results, right?
Correct.
Summary.
Great. So here we have the results up at the moment.
Okay. So we're about 50-50 with having a project or not having one and one coming in the future. So 10% have a project. Okay. Next, if we could.
Okay, great. So here we have poll number 2. So if the audience could answer some of these questions for us, that'd be great.
We could look at the results. It's just 2 check boxes. Okay, so we see from this that scanning is something that's just up and coming. If 18% are using scanning and 82 not, hopefully the other 9 are planning on getting into scanning in the future. It looks like you certainly are, so which is good. You're planning on taking advantage of technology to also be competitive and save some man hours. Okay, next.
Great, we have a couple more questions for you.
Okay. I think you can check multiple boxes if you're doing more than one, correct?
Yes, correct.
Okay. Okay, that's interesting. No oil and gas. So it looks like pretty much building, a lot of building. And then we got plant mining and structural, not quite, but close to an even split. Okay. I'm surprised there's no oil and gas. Okay, next.
It's the last poll.
Okay. Okay, so that's about 50-50. So that's good to know. And hopefully the other 50 are planning in the future to do construction verification, especially once we show you the technology that we have for it. All right, with this, let's turn it over to Trevor, and Trevor could take us through a hands-on demo and present the capabilities of Edgewise. Okay?
All right,
Trevor?
So first things first, a little bit about what I have up on screen. So this project right here is about 20 scan setups. All I've done to this point is I took my registered scan files, brought those into Edgewise, told Edgewise to go through, create my point cloud, and also go through and extract my pipes. So if I turn off my point cloud, all the pipes that you're going to be seeing up on screen here in a second, this is all automatically generated. So this is with no human effort whatsoever. This is the software finding them right off the bat from the point cloud. So this is going to be the starting point of my workflow or my 0 man-hour mark. So the first thing I want to talk about today is going to be the QA/QC tools. So for that, we put a lot of time and effort to developing some pretty awesome ones, mainly our part info spreadsheet, which is an intelligent spreadsheet that links my numerical data back to my visual model. Coming back to that concept of QA, I have the QA mode. Inside the QA mode, I have the bore of the extracted pipe in kind of this teal/green, or I have the bore of the extracted pipe in gray, and then I have all the points used to extract that pipe in this teal/green. So this way I can quickly go through and visually do an inspection of my pipes, see how they're fitting to the point cloud. If I see anything that I don't like, I can simply hit the delete key on the keyboard and I'll delete that pipe from my visual model. The next thing I'll go ahead and talk about is gaps. So for example, if I come over here and turn on my point cloud, we can see we had these structural support pieces of steel, and they blocked the scan coverage of the pipes behind them. And without any scan coverage, Edgewise simply does not know a pipe should be there. So instead of having to go through and do these connections one by one manually, what I have is the Easy Connect tool. And the Easy Connect tool is where Edgewise will automatically go through and insert both straight connections as well as elbows. So there you can see in black, that's everything that it just did right there.
That was live, and that's how long it took.
So besides the automated tools, there is a whole host of semi-automated tools for inserting straight connections as well as doing pipes, kind of a more manual way. But just in the interest of time, I'm going to go ahead and kind of skip those. So kind of coming back to more of the automated tools, another of the unique tools in the Edgewise software is going to be this one right here, the Clean Pipes tool. So the Clean Pipes tool is incredibly important because it does two main things to my model. It'll convert these black straight connections over and turn those into like true pipe, and also gives me the ability to control how as built or how as designed my model will be. What I mean by that is I can choose to either make more straight perfect pipes, or I can have the option to make a more a pipe that more accurately reflects the as built condition. If you might be a little bit hard to see, but if you look around this pipe right here, you can see it meanders a little bit to the left. It kind of swings back to the right. So again, my as-built conditions like the sags and deviations are being captured in my model. And again, as I mentioned, I have the ability to either straighten that back out, or I can have it capture more reality. Again, completely dependent on the needs of the project. Excuse me. So the next thing we'll go ahead and talk about is applying a standard to the model. So for that, right here, we have this pipe standard editor. I'll just go ahead and click on, say, my ASME spec at 150 PSI, and there you can see all the different values contained for my pipes, my flanges in the center, and all the way to the right, my different valves. The reason I point this out is I have the option to export this out as a CSV file that I can bring into Excel and use this as a template to create a, to create my own custom spec for use in the Edgewise software. Speaking of that, I can apply a standard to my model in one of two ways. There is a global option that will allow me to apply a standard to the model globally, as well as there's an option to do a by pipe run or for groups of pipe runs. I'm going to show it mainly as a global operation, and that's going to be the Apply Standards tool right here. So I'll go ahead and click that. I'll just go with my ASME spec at 150 PSI, click OK. There's a slight shift in the models. Now Edgewise takes the diameter that I found from the scan data and matches that up to the closest standard spec diameter. So now that I have my standard applied, this is where we can go ahead and talk a little bit about components. And one of the key tools I have for my components is going to be something called ClearView. What ClearView is a photorealistic rendering of the point cloud from a scanner view. So if I hop into one of my little scanner orbs, turn on my point cloud, you'll see I'll be presented with this kind of HD photo view. So the key thing is this is all a point cloud, meaning all of the modeling I have shown and will show I can do from this view. And this is one of the most important tools I have for my component placement. So I'm just going to go ahead, clean up this little section right here. I'm going to use some of my semi-automated tools. There you can see I'm inserting elbows. I'll put some T-joints over here on the left and right. And now I'll go ahead and place some components. Before that, we have two big drop-down menus, a list of all the various components inside the Edgewise software. So I'm quite literally just going to choose a flange gate at random, and that's going to be a click and drop. So I'll turn my point cloud back on, left click and place along the pipe. There you can see I now have my my valves in place. Once I do that, I then have this rotate tool where I can left click and drag, rotate these around, and again, visually fit them to the point cloud. So that is component placement. Again, click and drop it over to the point cloud. Right. Now I'll go ahead and get out of my ClearView, and let's go ahead and talk about the last thing, which is going to be the chain info spreadsheet. So the chain info spreadsheet right here allows me to manage the intelligence relating to my full pipe run, including diameter information, any layers and levels if I was going into AutoCAD, as well as pressure rating and standard information, and the Revit families. So if we're focusing a little bit on a Revit workflow, if I can, for when I export from Edgewise into Revit, I can choose one of 3 families. I can go pipe, conduit, and duct. So this will ensure it'll come into Revit under that correct family database. I also have a multi-edit tool down there at the bottom. Multi-edit does exactly what the name says, and I could say, group select a bunch of these little guys. So I'm going to go ahead and grab everything above like 40 mil, or below 40 mil, I should say. You can see it's highlighted in the background. I'll then go multi-edit, go to my Revit families, go to like conduit, and now this will all change over to Revit family conduit here in a second. And so again, this will ensure it'll come into Revit under that correct family database. So speaking of kind of the last bit, which is going to be the exports. So there's a couple different exports. We're going into the various CAD applications as well as going into Revit. So for that, for going into programs like Plant 3D, as well as CADWorks, we do have intelligent exports. And that's going to be, that's going to be right here. So we offer kind of these, we offer a couple more intelligent formats. So Plant 3D and CADWorks, it'll actually come in as intelligent Plant 3D piping, as well as intelligent piping in CADWorks. Also, there is a PDMS plugin, and that'll bring it in over as intelligent PDMS piping. For kind of more generic formats, there is a STEP as well as COE, and that'll come into AutoCAD as well as any AutoCAD-based applications as 3D solids with the layer information. Additionally, to the to the geometry, there is also a couple point cloud exports. So there is something, this one right here, this is the remainder cloud. So the remainder cloud is unique, and that is an export of all the remaining point cloud data that still needs to be modeled outside of the Edgewise software. Again, that way you're not having to deal with the information you've already worked with, but you can purely deal with the data that still needs to be worked with inside of, say, Revit. So for Revit, I'm going to pop this out. We actually have our own custom plugin. And so just like with all the other kind of things with the Edgewise software, or I'll kind of talk about this in a second. When I pop this out from Edgewise into Revit, it'll all come in as true Revit family objects with all the intelligences behind it. So I'll go ahead, inside of Revit, I just have a brand new project open, and I'll import this in, and so everything will come in from Edgewise into Revit. Also, the other thing to mention is the coordinate system. Edgewise will use and export all geometry to whatever coordinates are assigned in the registration process. So that was my model, my different disciplines. I can bring those into Revit, kind of one on top of the other, and then everything will come in correctly aligned inside of Revit. And that is a kind of a crash course, if you will, in the piping side of things. So next up, we have the structural steel. The structural steel operates off of a little bit different of an engine, and that engine is object detection. So what that means from a practical standpoint is the automation, instead of happening at the beginning of my process, more happens towards the end. So I've already created a couple little structural steel elements. I'll kind of talk a little bit about how I got to that point. So the centerpiece is this extraction tool right here. Works exactly the same as with the pipe, and I can draw a box around my element and then Edgewise pull it out. Unique to structure is these 3 drop-down menus right here. First one is the catalog. These are all the different steel catalogs we have contained inside the Edgewise software, as well as there's catalogs for doing, say, concrete and wood. Quick note, those catalogs are completely customizable. So if you do have your own custom steel sizes, it's a really quick process to add them in. Next up, there's a type. So there's I-beams, round tubing, channel, angle iron tubes, and T's, as well as cylindrical and rectangular concrete, and rectangular wood beams, and lastly, the size. There's the auto fit, as well as all the various sizes contained in my catalog. So to pull out this first piece of structural steel, click extract. I'm going to go ahead, draw a box around the point cloud data that makes up this element. Double left click in quick succession, give it a sec, and it's going to browse my steel catalog and then again choose from that catalog that element size that best fits. And all that happens in about half a second. And there you can see my first piece of steel. So coming back to that very important concept of QA, what I have is the smart sheet. And in there, I have two things. I have the spreadsheet over here on the right, which contains all my numerics. So I can see like all the length information, what catalog this came from, as well as the size. And over here on the left, I have the 2D view. Inside the 2D view, I have this outline of my steel that I can left click and drag to manipulate. And any manipulations I do in the 2D view will be mirrored in the 3D view and vice versa. Just for demonstration's sake, I'm going to go ahead and change the size to something wildly incorrect. There we go. So if I do have an incorrect extraction, I have a resize tool where I can quickly come through, left click and drag in the 2D view like so, and then Edgewise will instantly try to resize that element to the closest catalog size. So again, even if I do have an incorrect one, it takes me about half a second to adjust it. So now that I've gone through, I've QA/QC'd this element, I've gotten the correct size, I can take advantage of the fact that structural steel sizes in a project are often repeated. And that's using this little tool right here called Set to Selected. That'll put a true size where my AutoFit once was, and now I can go into areas where I might say have poor quality scan data. Edgewise knows the size. It'll simply take what I want and fit it to the cloud. Makes the extraction algorithm a lot more robust. Next up, Extend Tool. Extend Tool does exactly what the name says. It allows me to extend over and kind of build a section. And the keyword is, now that I have that section built, this is where I can bring in the automation. So the automation comes in the form of this pattern extract tool. What the pattern extract tool is and how it works is what I can do is I can define a grouping of elements. So in my case, everything I have selected in green. I then can define a direction and a spacing. And what will happen is the software will go out to that to the point cloud at that set direction and at that set spacing, looking for all the elements that I have selected. If it finds that element in the point cloud, it'll do an extraction, and so it's going to do a true mass extraction, fitting each and every element to the point cloud individually to get me my as-built conditions. This very kind of simple way to think about it is kind of like an array tool, except instead of just doing a blind array, it leverages the point cloud data to get individualized fits. And that is kind of where the automation with the structural steel portion comes in. So we're going to go ahead and let this run for a little bit longer, and then we'll, oh, when you know it's done. So there you can see everything right there. Again, going through the point cloud and fitting each one of these elements. And that fit is extremely important because, again, these like aren't, they're not going to be perfect for lack of better words. So each one of the spacings will be off, the orientations. Again, that's going to accurately represent the conditions of your model in the point cloud. Just like with the pipes, I can pop these out to a variety of applications. But for today, I'm going to go ahead and focus on popping this out to Revit. So I'll save this to my desktop right here. Looks like our pipes are done. Oops, where'd you go, Revit? So I'm going to go ahead and bring my structural steel on top of my piping. So I'll go ahead and do that. So again, just like with what I said, this will bring in my structural steel. Everything will come in as full Revit family objects. So all the intelligence, everything will be there. So at this point, once I have everything from Edgewise into Revit, there's no link saved back to the Edgewise software. So I can save this out as a Revit project, hand it over to the engineers, the architects, the detailers, and they can go ahead and finish it off. So I'm going to go ahead. Let's take a look at all of this. So there you can see I have my different pieces of structural steel. Piece of right there. I can select the pipe in the background. Again, all this is true Revit family objects. I can swap it out if I have a specific family that I want for my project. But at this point, again, I can hand it over to the engineers, the architects, the detailers, and they can finish it off from here. All right. So next one real quick is the ducting portion. So the ducting portion operates very similar to the structural steel, and that's that same object detection engine. So the key parts with the ducting is that if I can extract out my straights, Edgewise will Edgewise will allow me to kind of automatically do my transitions as well as my elbows. Additionally, the other kind of key part is that any complex geometry, if I can break that down into what Edgewise can do, then it's fair game for modeling. So I'm going to break down like that S shape in the back into kind of like 2 radius elbows connected by a little straight. So now that I have my straights extracted, I can then use my snapping tools to go ahead and align this. So, and now that I've done that, I can grab 2 pieces of duct, come over here to my connections, do like an add transition with the radius elbow, and there you can see I can start creating my run. Once I have that kind of rough fit, I can then left click on one of these. I can go ahead and click on one of these pieces. I have these large manipulator arrows where I can left click and drag and kind of size this to the point. And perfect. So that was done probably in about less than a minute. And again, all this can be exported into Revit as those true Revit family objects. Last but not least is the architectural side. So the architectural side right here, again, more similar to the piping with the automation in that we have our starting point is the planar model. So the planar model is all automatically generated right here. And what I can do to begin my workflow is I can use my pick level tool, isolate my various floor and ceiling heights like so. Once I have that done, I can then use the find walls tool, and this is where Edgewise will automatically go through and extract out my walls. And there are my walls. So again, that was all live. Pretty much it allows me to generate extremely flat, fast, accurate floor plans that I can then bring over into Revit. Speaking of that, I'm going to go ahead and pop this out real fast. We can go ahead and take a look at the plugin side inside of Revit. So unique to the architectural side is that in addition to writing out the geometry, it also writes out the point cloud data associated with that geometry. So that way what I can do is when it comes into Revit, it'll come in as designed. So perfectly plumb and square, perfectly, perfect walls. So using the plugin, I can display the point cloud data on the wall to show me how the wall, like my perfect wall, is deviating from my as-built conditions. Then using the Edgewise plugin, I have the option to refit that wall back to the point cloud to get me my as-builts. So now that I've talked about it, let me go ahead and show this. So just like we've done previously, I'll go ahead and bring the walls in. And again, these will be, one quick note on the wall thickness. If Edgewise has both the inside and the outside wall thick, or the inside and outside point cloud data, we'll try to extract out the wall to the true thickness. If it only has one set, it'll extract to the Revit default, which is 5 inches in the imperial. All right, so there are my walls. I'll go ahead, link my point cloud database right here. My database is linked. So just so we can see it a little bit better, I'm going to change over to a wireframe view. So I can click on a wall, do like, for example, a color by distance, and there you can see is my heat map. Green is good, yellow is points that are too close to my wall, blue is going to be points that are too far away. So I can kind of go through one by one, and this is where I then have the refit wall, and this is where I can choose how I want to refit my wall back to the cloud. So the original wall is going to be my perfect design wall. Best fit plumb keeps the wall perfectly vertical, but wiggles it to best fit to the cloud. And then the as-built face will do that, but in addition, create a rectangular mass object that's going to be the same size as that wall. And that rectangular mass is how it's going to get the vertical slant. So I can do that, do a color by distance just to see the updated fit. And there we go. And that's looking a lot better. So that is the building module. So that kind of wraps up with the Edgewise software. And that's kind of, again, kind of more of a little bit of a high level overview. So Otto, I'll go ahead and turn it back to you, and we can go ahead and talk about the Verity side.
Just as a wrap up, thank you, Trevor. Great job. And I hope everybody here saw the advantages that Edgewise could provide on your projects. It allows you to do more work with less people and also be competitive when you're bidding. So again, it allows you to get more work and do more work with less people. So hopefully you'll contact your resellers and ask about how you could get involved in utilizing technology to be more competitive. Okay. Yes.
I
see there's a question there from Becca.
Okay.
Just let me unmute Becca so you can chat to us, and then you can ask.
Okay.
Give me a sec. Hang on, I'm just trying to unmute him.
Okay.
His question was, I'm not sure if it's been answered already, because I'm not the technical expert. Does it process the data from GPR?
So if GPR is a ground penetrating radar, the answer will be no. So Edgewise will primarily deal with data coming from terrestrial tripod laser scanners.
Perfect.
Hello.
Hello. Does that answer your question?
Yeah.
Okay.
Because we can't hear you.
I can't hear you. If you could get closer to the mic, that'd be great.
Okay. My question was that can we process the data which comes from the ground penetrating radar?
Yeah, Trevor answered. The answer is no. We support any terrestrial scanner, so it has to be a terrestrial scanner, whether it's a Topcon or whether it's a Leica, whatever. But it has to be a terrestrial scanner, and we need all the scan locations.
Okay.
That's how we develop the point cloud database. Okay.
More questions for
Hello.
you? Yeah.
Any other questions?
We have one from Ken.
Okay.
Ken has asked, can you export to ArchiCAD software on top of Revit?
When you say on top of Revit, yeah, you could export to Revit, and from Revit, you could go into ArchiCAD. We also have a step export, and I'm pretty sure that ArchiCAD could read step. Okay. Does that answer your question?
So we're good to go ahead with the presentation again, and we'll take some more questions shortly.
Okay, let's do that. Okay. I'm sorry.
Yeah.
Okay, so what we're presenting now is Verity. We finished the Edgewise. Edgewise is used to extract a 3D model from your point cloud data. Verity is used for construction verification. And really, you know, some of the key, background of developing Verity is that we found that 5 to 12% of a construction project's cost is wasted on rework and, clashes in problem areas. For years, our current workflow is to spot check 5 to 10% with a total station or with a ruler and drawings. And with today's complex projects, it's totally not possible anymore. So with the falling prices of laser scanners, it's very feasible to do scanning during a construction site. And what that allows you to do, what Verity does, is it gives you 100% of the project in the same time that you spot check it. So basically, you're not getting 5 or 10%. You're getting 100% of the project, and it's looking for all the errors. And the nice thing is, it's doing it in a very shortened time frame. So you're finding errors early on, because during construction, if you wait 2 weeks or 3 weeks before you find an error, it becomes a lot more costly. Okay, next please. So what does it do? It's a companion tool with Navisworks, so you need Navisworks. It checks the accuracy of the 3D model that you have against the point cloud, and it compares the design fabrication model to your as-built. So basically, you've got a 3D design model, you scan in the field, it does a comparison, and it lets you know whether the object is there or it's not there, and also lets you know if it's out of tolerance. It gives you dimensional data as well as graphic data to show you what's out of tolerance. And the nice thing is it allows you to adjust the model in place to an as-is condition. And then if you're doing clash detection in Navisworks, you actually have the as-is condition. So you could do true clash detection. Okay, next. So How does it work? You load the design model in Navisworks. Next, you load the point cloud in Navisworks. Next, and then you identify and select objects. So if you only want the steel, you would select the steel objects. If you want only the piping, you would select the piping. If you're doing everything, you would select, whatever objects that you want to analyze. What happens then is Verity runs, and it comes back with a color-coded map, and it shows you in color what's there, what's missing, what's out of tolerance, what's occluded. It also gives you this tabular information, which shows you, for example, here, the magenta color shows you where the design had the beam where it was supposed to be. The cyan color shows you where it actually was placed. So you can see we got a little bit of a problem. And there's also a table, if you click the next thing, it shows you that there's vertical and horizontal deviations in exactly what they are by millimeter or meter or whatever unit you select. Next. And in this case, it shows you that you've got a major problem. This beam is off 188 millimeters. So if you're hitting those type of tolerances, you're going to have some design problems. Next, and the nice thing is it allows you to produce a report in either a CSV, which is an Excel sheet format. Next, it also gives you a HTML report. So the HTML shows you all the different views as well as the tabular data. You could also push the data back into Navisworks properties. And it gives you all the data inside of Navisworks. And we also have something called Smart Points. Smart Points show you exactly through a heat map how the members are. For example, here you can see that in green, it meets tolerance, this piece of steel here. As you get further away, it's getting out of tolerance. And when you get in the middle, it's way out of tolerance. So basically that beam has a twist or it has a bow. And the as-built Navisworks model, it shows you here where the beam was installed and where it was supposed to be. You could click a button, and next it'll show you exactly. It moves everything to an as-built location. So now you have true as-built for clash detection. Okay. Now, a case study. This is one of our clients, just to show you some of the benefits of Verity. It was a building, and their function was to review the steel structure and the slab edges. 583 steel items were analyzed, and the scanning, processing, analysis, and report generation took 16 hours in order to do 583 elements. Next. As a result, they found more than 50% of the steel was installed incorrectly, and some of the steel was out by more than 75 millimeters out of tolerance. If you could go back one real quick, you could see it's color-coded, right? So everything in green is okay within tolerance, everything in yellow is out of tolerance, and everything in red is either way out of tolerance or it's missing. Okay, next. In this case, this is interesting because the structure on the building face was out of tolerance by over 50 millimeters, so that could be a major problem. Okay, next. It also found that this beam, which is supposed to have a 10-degree slope, actually was installed straight. So if that was a roof and it expected some runoff or something like that, there was a problem. And Verity found that the spot checking, I don't think actually picked it up, but Verity was able to find that, and they were able to correct it before it left the fabricators. All right, next. And again, here's the third floor, and you could see the steel up on the third floor. A lot of it was out of tolerance. They actually got 36 elements that were out of tolerance, and as a result, they went back out and did a field inspection and proved that those 36 elements were out of tolerance. In conclusion, they identified substantial installation errors, which saved a lot of rework. Excuse me. And they were able to fabricate true as-built steel. So basically, a lot of the steel corrections they made before it left the fabricator's office, which resulted in not having to do as many, field corrections. So they were truly believers. They've used Verity on all future projects because of the phenomenal results that they had in using Verity. And with that, I'm going to turn it over to Trevor to show us a little bit about Verity. So Trevor, it's all yours.
All right, thank you, Otto. So with the Verity software, our starting point will have our point cloud data representing our as-built conditions, and also we'll have the geometry that we want to compare all loaded into Navisworks. So that's going to be my starting point. So the first step is going to bring the geometry that I want to analyze from Navisworks over into Verity. So any way that I can go ahead and select geometry is going to be a fair game. Also, the other thing I'd like to take some time to kind of stress is Verity is not a modeling application. Verity is a comparison tool. And the reason that's so important is because any kind of geometry is fair game for an analysis as long as it's present inside of Navisworks. So things like pump, equipment, floor slabs, it does not matter. It just has to be solid geometry. So I'll go ahead and let this run like so. Let me go ahead and open that up. And here we can take a look at the Verity application. So once I have all my geometry as well as my point cloud data loaded in, this is where I'll go ahead and use my analyze function right here. I can set my tolerance that Verity will use in comparing elements to the point cloud. And I'm going to go ahead and let this run. So during this process, Verity is going to be doing a couple things. Number one, it's going to make a judgment call saying, hey, is this element found within the point cloud? If it's found within the point, or if it's not found within the point cloud, it'll flag it as being, not found. If it is found within the point cloud, it's then going to look at that tolerance value and say, hey, is this element inside of tolerance of where it should be? If it's inside of tolerance, good, great, excellent. If it's outside of tolerance, what Verity will then do is it'll create a copy of the geometry. That copy of the geometry, it'll refit back to the point cloud to get the as-built conditions. In addition to all of this, it also is working with the point cloud data. So what it does with that point cloud data is it will classify it around the element to generate several heat maps. And what those heat maps allow me to do is it allows me to see a lot more of the subtle as-built conditions on my elements. Think of things like sags, any warping on my steel. All of those will really pop out using the heat maps. And later on, I'll show how we can actually export those heat maps out from the Verity application and bring those into another application like Revit, AutoCAD, and again, all right. So at the end of that process, what will happen is we get this little summary report. This is a nice little pie chart just kind of letting me know the results of my analysis. I can see, for example, down here in the bottom left, my metrics, or summary metrics. So I can see like the smallest and largest deviations. And again, just my little summary. Coming back to the Verity application, if I click on an element, I have a couple things. I have the point cloud data in white. The purple element is my element as it currently sits inside of Navisworks. And then I also have this teal element, and that teal element is the copy of the geometry Verity refit back to the point cloud to give me my as-built conditions. Down here at the bottom, I have my translation metrics. So I can see this element is about 7 inches out of tolerance in the worst spot, and it further breaks that number down into the vertical and horizontal vectors, as well as the project X and Y. So coming back to kind of the now what, a couple of the little highlights I'll talk about as far as the QA/QC process goes. Well, actually, let me go ahead and let's talk about those heat maps. So inside of Verity, there's 3 different heat maps that we have. So the main one that I want to show today is going to be this as-built heat map right here. You can see there's a color scale over on the right. Green is good. Yellow and red are points that are too far away from the element. Blue is points that are too close. And that allows me to, again, see any of these deviations, like right here, this big splotch of yellow in the center. That's a sag in my pipe. And so I'm pretty much going to go through it. I'm going to be checking kind of my various little deviations, making sure either things are in tolerance or out of tolerance. When I'm satisfied with the results, I can accept the status. That'll update put my initials as the reviewer, updates the review status. And I also have a notes and action required field. Those are just 2 text fields where I can input any information that I want. So after going through doing my QA/QC checks, I then want to talk about what I can pushing over my metrics from Verity into Navisworks. If I open up Navis, specifically the properties for this element, you'll see I have a Verity tab. So what I can do is I can push all the metrics over for the elements of my analysis, and as part of that, it'll color code the elements according to their conformation to the tolerance value. The big one is if you watch this element right here, I can shift it over from the as design position to the as-built condition that Verity found. I can either do that one at a time, or at the click of a button, I can do that for all the elements in my analysis. This was about 15 elements, but if you can imagine for about 1,500 elements, this is the way I can convert my design model to an as-built model at the click of a button inside of Navisworks. Lastly, let's go ahead and talk about the reports. So for that, there's two main ones I want to focus on. One of them is going to be the HTML. So HTML offers a nice, light little solution, and that the HTML file is only about a meg or two. Also, anyone with an internet browser can go ahead and open that file. So a common tactic is I can go ahead, email my results back into the field, and then someone with an iPad can double check my results there. And we'll go ahead and open that up real quick. So here's an example of the HTML report. I have my overall summary table, as well as these links where I can click on my individual items. I have these split views to see the element, as well as all the metrics, notes, action required, all that would be there. Again, full comprehensive report on this element that I can then browse through at my leisure. Also, you can export out the point cloud data from Verity through the Smart Points export. This is how I can export out my heat maps and then bring those back into, say, Navisworks, or take that a step further and bring that into, say, my Revit as a recap project. And lastly, we have this Publish tab right here. So that Publish tab contains our integration with BIM 360 Field, BIMTrack, and Procore. So if you're using any of those project management softwares, you can more or less you can take the Verity reports, push that as issues into that, and that way everything can be controlled and managed in one central location. And that is the Verity software, and that kind of concludes the Edgewise or the ClearEdge 3D product demo.
Okay, thank you, Trevor. Great job. For all you attending and saw what the power of Verity is, I just want to say that there's a very, very quick payback with the Verity software. Imagine if you've got a construction project, and construction projects are not cheap. They're very costly. They're in the millions or hundreds of millions of dollars, some of these projects. If you could find errors, a week or 2 weeks or 3 weeks sooner than they're located in the field, could you imagine the big payback in terms of man-hour savings, in terms of fabrication savings, in terms of installation savings? The worst thing is if you get an item there, you want to install it, and the pipe is 50 millimeters off, then you got a real problem. Then you got to go back to the fabricator, or you got to do field, adjustments. So Verity actually helps keep your project on schedule and actually saves you, quite a bit of funds. General contractors typically have a contingency fund, which is used to cover any errors that show up in the field. And you could imagine they want to keep that contingency fund and not have to spend it. Verity gives them the ability to maintain that contingency fund and not have to spend most of it. So it certainly is a very, very powerful software, and we've had phenomenal results worldwide. And with that, I'll open it up if there's any questions.
Question. We have one more question that's come in from Tim, asking, are you able to render an architectural model with Edgewise?
The answer is yes. We do support, as Trevor showed you, what we do support are walls and windows, and you could take that into Revit on the architectural side.
Great. Are there any other questions out there? Anybody want to ask any questions? Let's give them a few seconds.
Okay.
Oh, there was one question, Jacob Kitali. Jacob Kitali asked, is it independent software or a plugin into CAD software?
Edgewise is totally independent. It's middleware. We don't care what scanner data comes in, and we don't care what CAD engine you go out to. So it's truly middleware. And Verity is dependent on, it's a companion product to Navisworks. So you need Navisworks to run it for Verity. Okay.
Great, thank you. Any other questions out there? Well, in that case, I will hand back over to Michael. Michael's still online?
Yes, indeed. Thanks, Gillian. Look, really, really exciting. I think we can clearly see why using ClearEdge would give you a competitive advantage. I'd like to thank everybody for attending and their time, and a big thank you to Otto and Trevor for sharing their insights. And just a reminder to everybody that a link will be sent out of the recording to all registrations and as well as attendees. You'll also be contacted by an appropriate local partner reseller to have a conversation regarding your interest on a one-to-one demo. So please look out for that. We're excited about making those calls and helping our partners to make those calls. And then, thank you once again for everybody being here, and have a great quarter. Thanks, guys.
Great.
Thanks, Michael.
Thank you. We have one last question that's come in. And that is, do you need to have a scanner tool to use the software?
Yes, the software is based on having a scan data.
Okay, great.
Okay.
Don't think
it's handy that you can just know to ask that question, Gillian, because I know people who have scanners.
Right, that's a good lead-in for a scanner sale. But to extend that question further, for Edgewise, it has to be a terrestrial scanner, and for Verity, it could be either a terrestrial or a SLAM scanner. Okay.
Great. Well, I think once again, thank you very much, Otto and Trevor, for your time this afternoon. It's been very insightful. Thank you to everybody that's logged on. I think we've come to the end of the presentation and the webinar. We will be sending the recordings out to all of you, and do feel free to reach out to us if you have any other questions that we can answer for you.
Okay, thank you.
Great. Thank you very much.
Thanks, everybody.
Bye.